Welcome to MRU E-Learning powered by Malla Reddy University. Hello all, this is Dr. Shilpa, Associate Professor in the Department of Information and Technology, Malla Reddy University. So today's topic is about ANOVA. Let us see what is ANOVA. ANOVA stands for Analysis of Variance. See, it is nothing but an extension of t-test. So if you are having two sample means with you, you can perform the t-test. But performing the t-test with ANOVA also gives the same results. But the problem is when you have samples more than 2, we need to go for ANOVA. So that means if you are doing multiple t-test for the same sample that means there is a chance of increasing probability error. So we get a type 1 error called as type 1 error. So type 1 error is nothing but the error where there is a rejection of null hypothesis even though the null hypothesis is true. That means then the alternate solution for this is we go for ANOVA. That means when you are having samples more than 2, we go for ANOVA. For samples below 2, we can use t-test or chi-square test because there is a chance of error probability proning more. You can see from the diagram, there is a problem with this type 1 error, alpha. Alpha is the level of significance. Coming to the types of ANOVA, we have 2 types of ANOVA, one-way ANOVA and two-way ANOVA. In one-way ANOVA, it involves only one independent variable and it can compare 3 or more levels of signal factor. Coming to the two-way ANOVA, more than one independent factor is allowed in two-way ANOVA and it can compare the effect of multiple levels of a two-factor. Coming to the hypothesis, we have 2 types. One is null hypothesis and alternate hypothesis. So here in null hypothesis, we assume that all group means should be equal. That means mu1 or mu2 or mu3 up to mu n, all the means should have the same. Next, coming for the alternate hypothesis, at least one pair of group should be different. That means mu1 is not equal to mu2, is not equal to mu3 and so on up to mu n. Now how to perform the ANOVA test? So we perform the ANOVA test by taking the ratio of variance between the groups and to the variance within the groups. So between the groups and within the groups. So let us see what do you mean by variance between the groups and within the group. So the distribution allowed here is F distribution. That means instead of t-test or chi-square test, the distribution allowed is here F test. So let us take an example where you can easily understand how to calculate the variance within the distribution. So let us take that the samples, 3 samples I am taking, x1, x2 and x3. Okay, so these 3 samples, if I want to calculate the mean, so generally here, within the group, if I want to take, I'll get somewhere the average over here. Okay, so this is the distribution within the variance within the distribution. Okay. Similarly, between the groups, I want to calculate the variance. Then again taking the same 3 means x1, x2 and x3. Now, to differentiate between all the 3 groups, we draw the curve and take from the center position, we'll calculate the distance from x1, x2 and x3. So you can see here, we draw a line here and calculate the distance from mean 1, sample 1, sample 2 and sample 3. Okay. So assuming the same hypothesis for null, all the means should be same, and for the alternate hypothesis, means at least one group of means should be different. That is, mu1 is not equal to mu2 is not equal to mu3. Okay. Now, once you get this variance, so we can find out the ratio between variance between and variance within. And total variance, if you want to calculate, just we need to sum these two between and within variances. Now, when we are calculating the ratio, if the ratio is exceeding 1, then we have to reject the hypothesis. And if the ratio is falling less than 1, that means we fail to reject the null hypothesis. And even if the ratio is or equal, we fail to reject the null hypothesis. So these are the conditions. Now, before going to start the test for ANOVA, we need some assumptions. That is, the samples we are taking from the population should be of normal distribution. And each sample should be random and should be chosen independently. And all the group which should be having equal variance. And the data we are collecting and all that should be independence. So with this, we move on to the F-test. Now let us take an example to better illustrate about the ANOVA further. So when can we reject the hypothesis, or when can we fail to reject the hypothesis? So here I am giving you an example by taking 3 groups, group A, group B, group C, and each having 4. Now if I want to calculate the means, just we will take the sum of observations for each group. So group A we'll sum all 50 plus 52 plus 48 plus 49. So we sum and divided by number of observations. So we get these values for group A. Similarly for group B and for group C, we got these values. Now there is one more mean, that is overall mean. So to calculate the overall mean, just we will add these 3 and take divided by number of observations. So these 3 divided by 3. So we will get the overall mean as 56. Now this is important. Individual mean we have calculated and overall mean we have calculated. The next things to calculate the hypothesis is we should take some terminology. That is, we have to find out sum of squares. See, we have to find out sum of squares. Sum of square within the group, that is between the groups, it is represented by SSB, and sum of within the distribution, that is SSE. So first we will calculate SST and SSB. Then your SSE will be nothing but your sum of square total minus between the groups. So this will be your SSE. Now let us how to calculate this. We will see how to calculate SSE. Now SST is nothing but we will calculate it by summation of individual by mean whole square. Okay. So here the samples from 50 minus 56. 50 minus 56. So if you calculate this, we are getting a total of 356. Okay. The next slide. Sum of squares between the groups, that is represented by SSB. Now how to calculate SSB? SSB is we have to take the mean summation of between the groups. This means, so we have 1, 2, 3, 4. So 4, next 4 into how much we got here? For the group A, 49.75. So 49.75 minus overall mean is 56. Okay? So if you sum all these values individually, we are getting. So this is sum of squares between. Now we know sum of squares and we have SSB. So we have to find out SSE. Okay? So your SSE is nothing but your total, what you have calculated, sum of squares minus between the groups. So sum of squares we got as 356 minus 325.48. So we are getting within the group we are getting as 30.52. Okay? So these three terms, SST, SSB and SSE. SSE. Next, to find out, there is one more parameter called as degrees of freedom. So degrees of freedom can be found by, again we have 3 degrees of freedom between the groups, that is DFB, and within the groups, that is DFE, and total degrees of freedom, DFT. So DFB, let me calculate total. So what is my total number of components? You can see from the table. We have total 4, 4, 4. So we have 12. So your degrees of freedom is 12 minus 1. So this is n minus 1. We have DFT as 11. Similarly, we have to find out between the groups. Between the groups, it's represented by DFB. So how many groups are there from the table? We have group A, group B, group C. 3 groups. So 3 minus 1 is 2. So now total degrees of freedom are 11. Degrees of freedom within the groups are 2. And between the groups are 2. And within the groups, DFE, we can do this by n minus k. So n is 12, k is 3. So we are getting 9. So why these degrees of freedom are important? Why these degrees of freedom are important? Here we can calculate MSB mean square. Now we have found out SSB and SSE, SST. We can calculate the mean square from within it. So to find out MSB, we have SSB divided by number of degrees of freedom. So degrees of freedom is DFB. So SSB we got from the table 325 and degrees of between the groups we got as 2. So we are getting 162.74. Then next we have to calculate MSE. Similarly, we have found SSE divided by degrees of freedom. So SSE is 30.52 we got, and degrees of freedom within the groups we got as 9. So we will get the ratio of 3.39. So once we have calculated the mean square between and mean square error, the next thing is F static. So to calculate F static, there is a formula. We need to divide the ratio of mean square between by mean square error. So mean square between we got 162.74 and mean square error we got as 3.39. We are getting the F static as 48.01. So remember this value. We'll go to the next slide. So here, this is the summary where we have calculated the SS, degrees of freedom, mean square, and F static finally we got as 48.0. We have taken the help of all this between the groups, within the groups, total degrees of freedom and mean squares calculated. Then we have found out finally F static value we got as 48.01. Now with this value we can say we have to compare this F static value with the critical value in order to determine whether there is a rejection of hypothesis or not. Now the calculated value comes around 48.01. The critical value and we are assuming that the alpha level of significance value is 0.05 and the degrees of freedom within and between are 2 and 9. So for these values we are getting 4.26. You can see from the table. So these are the degrees of freedom on the left hand side from 1 to 10, and for the values 2 and 9, so the intersection of these two is 4.26. Okay, we got 4.26 as critical value. This is the table which gives us the critical value. Okay, now what we got? F, calculated F, that is from F distribution, calculated value we got as 48 and critical value we got from the table as 4.26. Okay, so you can see there is a lot of variation from calculated to critical value. That means calculated value is far greater than critical value. That means we will reject the hypothesis. How? You can see here the variance between and variance within. So this statement, it is satisfying the first statement. So 48 is greater than 4.2. So that's why we are rejecting the hypothesis. This is the conclusion. So you can see that from the conclusion, I can say that if you are having high between the groups variation, that means large variation between the groups, or low SSE or some of small variation within the groups, the value of F will be large and the hypothesis will be rejected. Thank you all.